Chapter 12, Part 3, Exercise Selection. Chapter 12, Part 3, Exercise Selection. Part 3. Exercise selection is a process of choosing exercises for program design that allow for the optimal achievement of the desired adaptation. Proper exercise selection has a tremendous influence on the outcome of the training program. The human movement system is a highly adaptable organism and readily adjusts to the imposed demands of training. Principle of specificity. Therefore, exercise should be specific to the training goals and based on the principles of the exercise selection continuum. In the OPT model, exercise from components flexibility, core, balance, plyometric, speed, agility, quickness, and resistance training. For example, exercise used are characterized by quickness and resistance training are characterized by the adaptations for which they are primarily used. For example, exercises used in phase 1 of the OPT model, stabilization, are termed stabilization level exercises because they are used and progress for stabilization adaptation. Similarly, the exercise used in phases 2 and 4 are termed strength level exercises, and exercises used in phase 5 and 6 are termed power level exercises. Exercises can be broken down simplistically into 3 different types based upon the number of joints used: movements, performed, and desire and adaptation desired. Single joint focus on isolating one major muscle group or joint. Multi-joint requires the involvement of 2 or 3 joints. 3. Total body includes multiple joint movements such as squat, clean, lunge with bicep curl to shoulder press, lunge, curl, and press. Exercise selection continuum. Training adaptation, stabilization, strength, and power. Those are the training adaptations. Training levels, stabilization level, strength level, power level. That's the training level. Exercise selection, total body, multi-joint, single joint, controlled, unstable. Total body, multi-single joint, exercise selection. Total body, multi-joint, explosive. Exercise selection examples: stabilization, step-up balance to overhead press. The multi-joint, single leg tubing chest press, single leg cable row, single leg dumbbell shoulder press, single leg dumbbell curl. Strength level, total body, squat curl to overhead press, bench press, multi-joint bench press, seated row, shoulder press machine, squat, standing barbell. Power, squat jump. 2-arm medicine ball chest pass, medicine ball pullover throw, medicine ball oblique throw. Single joint, the joint is not available. And that was the exercise selection. The OPT model enables the sports performance professional to select the appropriate exercise for each athlete based on training goal. Completing a sports performance assessment and reviewing the specific training goals will lead to inclusion of appropriate exercises into a properly planned integrated training program. For example, to develop optimum stability, traditional exercises can be progressed to a more unstable environment, such as standing up to 2-leg stagger stance and single leg, or from a stable environment to an unstable environment, AirX pad, stability pad, ball, Bosu ball, etc. Research has shown that exercises performed in unstable environments produce superior results for the goal of stabilization and training the core stabilizing muscles. Stabilization exercise examples include single leg cable rows, single leg dumbbell shoulder press on a half foam pad, single leg squat, kettlebell suitcase carry, rotational cable chop, single leg RLD. Any resisted exercises can develop strength as long as the load is sufficient to stimulate improvements in force development. To develop strength and muscle coordination throughout the body, the use of total body and multi-joint exercises has been shown most beneficial. Total body exercise increase neural demand by requiring numerous muscle groups to work in coordination, both timing and force contraction, to execute complex movements. Since most athletic skills also involve total body complex movements, the use of total body exercises is a great way to increase the transfer of training from exercise to sport. Neural demand continuum. Neural demand refers to the challenge an exercise place on the balance and stabilization system of the kinetic chain. Integrated training progressively and systematically alters the base of support, center of gravity, and neural demand to improve neuromuscular efficiency, dynamic joint stabilization, and functional strength. The most important aspect to remember when altering the neural demands is safety. Progression should proceed from stable to unstable if the goal is to enhance stability. Neural demand continuum. 2 legs, lower body. The neural demand continuum, lower body. 2 legs, 1 leg, 2 legs unstable, 1 leg unstable. Upper body, 2 arms, alternating arms, 1 arm with rotation. The neural demand continuum. Sensory, floor, sport beam, foam pad, dyna disc, wobble board. The total body exercise example include clean press, barbell or dumbbell, standing rows, machine, cable, barbell, overhead squat, barbell or dumbbell. To develop optimum power, plyometrics and explosive medicine ball exercises can be performed during functional movement patterns. Power exercise examples include overhead medicine ball throw, medicine ball chest pass, medicine ball soccer throw, squat jump, tuck jump, box jump. Exercise progression, stabilization continuum, floor, sport beam, foam pad, dyna disc, wobble board. Lower body, 2 legs stable, stagger stance stable, 1 leg stable, 2 leg unstable, staggered stance unstable, 1 leg unstable. Upper body, 2 arm, alternating arms, 1 arm with trunk rotation.